arguments. So what we can do here, we can pass a member of struct variables to a function. So we've got this function, and this is a member of this structure. Okay, so we can pass it to that function to be manipulated. Even we can pass the entire structure into a function. For example, show data of stu. Let's say this function just prints out the data, so it prints all the parameters belong to that structure. Okay, so whenever you can use the reference parameter here, you can use the structure name in order to be modified. Let's see, we've got an example here, and we've got this structure, and this is the tag name, and we've got those parameters, part number, and so example, we've got a void show item, and we've got the structure name and p. This is going to be any variable which you can name anything. So show point set precision to 2. This is not just it gives you a precise points after the decimal value, and then we're printing out p dot path name. Okay, so this p is going to belong to that inventory item. So the parameters of that inventory item are part name and description, on hand, or price. So p dot part name, p dot description, p dot on hand, p dot price. Okay, so we can pass any structure to any function. So sometimes using the value parameter for structure can slow down a program. So instead of that, we can use the reference of the parameter, as we've got here, and we can use constant reference parameter, which can only allows read-only access to the reference parameter. Okay, so you can only read data from it. For example, we've got a constant inventory item. We just revised the previous example. We need to do that, and then we are going to say the reference of that structure. So, and in this case, the program, the content of the program is the same, but it speeds up the program because we've used the reference instead of the values. And returning a structure from a function. So any function can return a structure, but the type of the function must be in structure type. So this is a structure, and this is going to be the function to be applied on that structure, and we are calling that function to be applied on that structure variable. Okay, so we can use it for internal use or for use with the return statement whenever we are returning a value from a function. And in this case, we've got this function, and we've got this tag name, and we are using to access all the members of that structure variable, which is you are entering data to the student ID, to the this is going to be a parameter belong to that parameter which is inside this tag name. Okay, as we said, we've got the nested structure, and for this one as well, and the year in school, temporary student dot GPA, and then we are returning what? Temporary student, which is the tag name. And in this example, constant double pi equals to that value 3.14, and we've got this structure, which we've declared this structure, and it is circle, and the parameters are radius, diameter, and the area. And look, we are defining this function circle, which is the tag name, the tag name, and the get info is the name of the function. And let's say, what do we have in the get info? Here is the get info. We are just getting the information, so we need to define this temporary structure variable, which is temp circle dot diameter. We get the diameter, and the radius is going to be the diameter divided by 2, and then we are going to return the temporary circle. Okay, so we are getting those two variables, diameter and the radius. And let's say, what do we have in the main circle C? We are defining a structure variable, and then c dot get info, c equals to get info, so that means those data which we had in the get info function are going to be getting through this one. And then we got the area, sorry, we didn't calculate the area there, we hadn't calculated the area, sorry, in the get info function. But now as long as we have applied this function on that structure variable, we can use those data which we got from the function. So c dot area equals to pi multiplied by power bracket c dot radius, because we got the radius in the previous in the our defined function, and then we are printing those values. So this is how you can return a structure from a function. So you can return all the members of a structure from any function. And pointer to structure, we know that we've got a pointer to normal variable, but even we can have a pointer to a structure variable. So a structure variable has an address. Okay, pointer to structure are variables that can hold the address of a structure. As we know that if you use pointer, that means we are accessing the address of that variable. So in this case, we are accessing the address of the structure variable, and we can use the AND operator to assign an address. Here we can assign this address to this pointer variable, and even we can use them as a function parameter. We can see it in the next slides. So in this case, if we want to dereference pointer variable, so we use this star student pointer in order to access the reference of that variable, but you can use those brackets as we've used here in order to access the what is called the data itself of the student ID. So we got the student ID here, but without that we are only accessing what is called the address of that parameter, and we can use it in this way: structure student pointer, and we can use this minus sign and this this rectangle bracket, then the parameter of that what is called the structure. So in this case, we are using void get data, the structure name, and the the reference of the tag, and then we can say that tag of name get line, that tag of name, as we know that whenever you are using C in dot get line, you need to write down the length as well. So instead of using the dot, we can use in this way s, and then ID name s dot credit hour s, not a dot, actually these two signs, minus and the rectangle bracket GPA. So you can use in this way instead of using the dot. And when in the future we are learning database or relational database, you will find out why this one is very important to learn. And what is union? Union is similar to structure, but all members share a single memory location. That means all the members are stored in one memory location, okay, or inside one address inside the memory. Or in this way, we can say only one member of the union can be used at any given time. Only you can use one of them, because all of them are stored inside one memory location. So we need to declare using union, so otherwise it's going to be a normal structure. Variables defined as flow structure variables. So what you can define the variables of that union as the way we have used for the structure. So what are the anonymous union? So a union without a union tag. So for example, you don't have any tag here. So instead, if you are declaring it outside a function, we need to use static, and it allocates memory at declaration time. Whenever we are declaring this union, it allocates a memory location. So we can even access to any member directly without using a dot operator. So it uses only one memory location, so that it saves spaces. And let's talk about the enumerated data types. And so it's a data type that is defined by the programmer or by you when you are writing your program, and it's going to be a data type. So it's going to be consisting of some values which known as enumerators, okay, and they are representing integer constant. For example, enumerator day, which is going to be the name of the variable, and inside day we've got Monday, Tuesday, Wednesday, Thursday and Friday, and then those are going to be translated to integers. We can discuss in the upcoming slides. And those Monday, Tuesday, Wednesday, Thursday, Friday are called enumerators, and they represent some values which belong to day data type. Okay, so day is going to be a data type, and those values between those two curly brackets are going to be what is called the enumerators belong to that data type. Okay, so this is, for example, you can say integer, integer or string or whatever. So there may be some values. So these values are called enumerators that belong to this data type. So if you say they are string, they are going to be placed between quotes, double quotes, but they are not string here. You know, they are identifiers or enumerators. So whenever you are creating an enumerated data type in your program, you can define variables under that data type. So we already defined day, and then we can say day workday. Okay, so this is going to be a variable belong to the data type or in that data type. Okay, so as it's written here, the statement defines workday as a variable of the day type. This is going to be the data type, and this is going to be the variable. So here, after creating that variable, we may assign any enumerator or any value inside that data type to the variable we just created, which was Monday, Tuesday, Wednesday, Thursday, and Friday. So we know what are the enumerators, so we just think of them as an integer named constant. Okay, so internally the compiler assigns integer values to the enumerators. For example, here we got Monday, Tuesday, Wednesday, Thursday, and Friday. So the compiler translated them to integer values beginning with 0 or beginning at 0. So in our program we have said enum day, Monday, Tuesday, so but in memory they are going to be represented as integer and starting from 0, 0, 1, 2, 3, 4. Okay, so whenever we are printing out the enumerators, the output will be produced like this: 0 to Monday, 2 to Wednesday, and 4 to the Friday. And this is very important. We cannot directly assign the integer value to the variable. We need to assign the enumerator. Instead of that, if we want to assign the integer value, we need to static cast it. Static cast of the data type and 3. So this 3 is going to be translated to what is called the enumerator, which was, I think, 0, 1, 2, 3. It's going to be Thursday. So this is how you can assign a direct integer into what is called the day data type or the enumerator data type. So as we said before, the enumerators are translated to integer inside the compiler, so we can use them as integer. For example, integer x is a variable which can hold all integer values, so you can say x equals to Thursday. In this case Thursday was translated to 3, so 3 is going to be stored inside the x variable of integer type. So you can act with them like integers, and we can compare them. We can compare the enumerators. If Friday greater than Monday, yes, it is, because it was 4 and this one was 0, so Friday is greater than Monday. And in this example we can use the enumerators data type, so the day is going to be a data type with holding those values, and they are going to be 0, 1, 2, 3, 4, and here we've got for index equals to Monday or 0. So this Monday is going to be translated to 0, because we've said that index is an integer, so you can say Monday instead of 0, or then index, if index is less than or equal to Friday, then index plus plus, so cin cell of index, and then the program is going to be like this. And finally, what is going to be what the program does, the program calculates the total of those values which are entered to the sales array, and then it shows you the total in fixed point notation. So inside the previous program we are getting the sale for each day, sales of index, so the index are starting from Monday up to Friday, excluding Saturday and Sunday. So this is the same as the previous program. So instead of using 0, 1, 2, 3, 4, we are using the day, so it's going to be much clearer. So we've got anonymous enumerated types. Like here, we can exclude, we can discard the name. In the previous example, we could remove the day data type. So what happens here, it just doesn't have a name, so it doesn't matter if you don't have a name of the data type. So that at the end, in any case, if you got the name here or we don't, those variables are going to be translated to, those values are going to be translated to integer values. How to use the math operations with the enum variable. For example, we've got day 1 and day 2. So day 1 and day 2 are two variables of the data type. So you can say day 1 equals to the Tuesday, it's alright. So you can say day 2 equals to day 1 plus 1. So the value inside day 1 is Tuesday, which is going to be translated to 1. So this 1 plus 1 is going to be 2, but 2 is going to be stored in day 2, which we can't use. You can't store integer value in what is called a variable which its data type is enumerator. We need to store a string value which is actually not a string, but this it's going to be called an identifier, and it's going to be converted to integer by the compiler. So whenever you are calculating this is going to be 2, and 2 is a direct integer, and it can't be stored inside a variable which its type is enumerate data type or its day. So make sure that you don't do that, but you can store any identifier inside any enumerated variable, or any variable of an enumerated data type of variables. So in order to fix this, we need to use static cast of day 1 plus 1. Okay, so in this case it translated the integer to what is called the the identifier which was stored in day 2. Using the enum variable to step through an array's element, like here for example we've got sales array, and let's start from again, because the enumerators are stored in memory as integer. We know that this is going to be the integer values inside the memory, so we can use them as array subscript. For example, sales, which is a variable and its size is 5, is sales of Monday is going to be sales of index 0. Why? Because when this one is going to be translated to inside the compiler is going to be 0. So sales of index 0, 1, 2, 3, 4. Okay, so that means we've got 5 indexes from 0 up to 5. So you can use the enum variables as integers here, but we can't use increment operator or decrement operator or on any enum variable. Like here, day workday, which is workday is an enum variable. We say workday equals to Monday, right? It's less than or equal to Friday, right? But we can't say increment workday. Okay, we can't do that, so this is going to be an error. So again, we can solve this by using static cast of day type workday plus 1. So this workday is going to be the new workday, the new one will be the old one plus 1. That means we are incrementing then static casting in order to be the type of that type. So we can have this example, enum day, those values, and day of workday, and we've got sales of array, which is going to be the size of it going to be 5, and we've got day workday, so we've got a variable enum variable, its name is workday, and the type of it is day, which we've already defined as enum. And then for workday equals to Monday, workday is less than or equal to Friday, workday equals to static cast day workday plus 1, as we discussed before. We can do that as a loop, and then we just printing out the what is called the getting the printing out the workday. So the workday starts from Monday, and then getting the sales of that day, of that working day, and then we are calculating the total, and then we are displaying the total in fixed point notation. The output of the program is going to be like this. So in each program you need to have a unique enumerators, like here for example we've got enum presidents, those names, and enum vice presidents, those names. So this one is declared twice, so this is going to be error, or it shows you an error because it is declared twice. And we can declare an enumerated data type and define one or more variables of the type in the same statement. For example, so we can declare an enumerated data type like here car, and we can define one or more variables of the type at the same time at the same statement. So we have declared this data type and the enumerators are those. At the same time we are declaring this variable, so this variable is going to be the type of the car. So this is how you can declare an enumerated data type and define some variables